Okay, topic is STP states. So we have, disable state, we have blocking state, then we have listening state, then learning state, and then finally forwarding state. So STP port will goes through these states, right? Whenever ports will come up, ports will go through these states. Disable is like STP is not running on switches or interface, right? Means STP enable interface is not sending any BPDU or not receiving any BPDU. It is like shut down, right? So when port will be shut down, STP states will be disabled. It will show you disable state. In disable state, switch cannot send BPDU, cannot send BPDU, cannot receive BPDU, cannot send data, cannot receive data, and cannot learn MAC address, right? In both state, in blocking, see what is the difference between disable and blocking state. Difference is only one, right? Blocking state can also not send data, can also not learn MAC address on the interface, right? And disable state can also not learn MAC address and cannot forward data. Difference is disable state cannot send BPDU as well as cannot receive BPDU, but blocking port cannot send the BPDU, but blocking port can receive the BPDU, right? Blocking port can receive the BPDU but cannot send the BPDU, right? And data transfer will not happen in blocking state, or switches cannot learn MAC address in blocking state. So whenever a port will come up, first state will be blocking. When we will run no shut command on the interface, port will be in blocking state first, and quickly state will move from blocking to listening. Quickly state will move from blocking to listening, and in listening state, switch is going to spend 15 seconds. In listening state, switch is going to spend 15 seconds, and in listening state, switch can forward the BPDU, it can forward the BPDU, it can learn the BPDU, but again it cannot learn MAC address. It cannot learn MAC address in learning state. It cannot send user data. It cannot send user data. It cannot receive user data. It cannot learn MAC address, but listening state can send the BPDU or can receive the BPDU. After that, learning state. After 15 seconds, state will move to learning state. In learning state, again switch is going to spend 15 seconds, and in learning state, again switch can send the BPDU, can receive the BPDU, but it cannot send the data or it cannot receive the data, but switch can learn MAC address, right? So actually in learning state, switch will learn MAC addresses. After 15 seconds, state will move to forwarding state. State will move to forwarding state, and in forwarding state, switch can send BPDU, switch can receive BPDU, switch can send data as well, and switch can receive data as well as switch can learn MAC address, right? So guys, total time that a port will takes to come in forwarding state from blocking state is 30 seconds. 15 seconds in listening state and 15 seconds in learning state. Got it? All switch port will pass through the blocking state to avoid any pre-existing loop, right? Blocking state is for pre-existing loop. If there is already loop in the topology, then how to avoid that loop? That's why we have blocking state. So whenever a port will come up, first of all, port will enter in blocking state, right? If that port role will be DP or RP, then only port role will move to listening and learning and forwarding, right? To listening, you can say. If port role is going to be alternate, then state will not move to learning. State will be still in blocking. And as I told you, a blocking port can only receive the BPDU, cannot send the BPDU, cannot send the data, cannot receive the data, and cannot learn the MAC address. Okay, after that, state will move to listening quickly. A switch port will start sending BPDU in order to participate in STP election in listening state. In listening state, switch will start sending what? BPDU. BPDU to participate in STP election. Not participate of root port only, right, or DP. Election of root bridge, root port, DP, right, and alternate port. So port will become alternate or DP or RP, right? That will be decided in listening state. Which switch is going to become root bridge, that will be decided in listening state. But again, data forwarding is not possible in listening state. So after 15 seconds, state will move to learning. In learning state, switch is going to learn MAC addresses, and then state will move to forwarding. So in learning state, only DP and RP will move. Alternate port will be moved to blocking state. Let's say here in listening state, one port is going to become what? Port role is alternate. So that port will move in blocking state from listening state, right? If port role is DP, then port state will move to learning state, right? Right. So first of all switches will send BPDU from their all interfaces, because at the initial time all switches will think I am root bridge, right? But when switch 2 and switch 3 will receive BPDU of switch 1, these switches will came to know that I am not root bridge. Who is root bridge? Switch 1. So these two port will become what? DP. In which state? Learning state. Sorry, listening state. This port will become DP in listening state. And then state will move to learning. This port will also become what? DP. Then state will move to learning. This port will become what? RP. Then state will move to learning. This port will also become RP. Then state will move to learning. This port will become DP. Then again state will move to learning, and this port will become what? Alternate. So state of this port will move to blocking. Okay. So this is STP states. Just give me guys 1 minute. Okay. So in this scenario, this port is block. This port is block. Yes or no? Means my logical topology is this one, right? So switch 1 will learn MAC address of computer A on which interface? A MAC address on which interface? This is, let's say, 0/1. This is 0/2. This is again 0/1. This is 0/2. This is 0/1. This is 0/2. So switch 1 will learn A MAC address on 0/1 interface. Yes or no? A MAC address. And B MAC address on which interface? 0/2. Right? Switch 2 will learn A MAC address on which interface? Let's say this is 0/3. This is 0/3. So A MAC address on 0/3 and B MAC address on 0/1. In the same way, switch 3 will learn A MAC address on 0/1 to this interface, A MAC address on 0/2 and B MAC address on 0/3. Right? Now let's say guys, here I have removed this computer. Here I have removed this computer. I have connected one new computer here whose MAC address is C. His IP address is 10.1.1.10.1.1. Or let's say here I have attached this computer 10.1.1.2, and here I have attached this computer A. Now computer A is connected with switch number 3. IP address of computer A is again 10.3. Fine. Now 10.1.1. Sorry, this IP address is 10.1. IP address of PC3 is 10.3, and here this PC IP address is again 10.1. MAC address of this PC is A. Now if 10.1.3 want to communicate with 10.1, or let's say 10.1.1.2, 10.1.1.2 want to communicate with, let's say 10.1.1.1 want to communicate with 10.1, right? So it will it will encapsulate ICMP packet. Source MAC is going to be C and destination MAC will be what? A. Right? It will forward the packet to switch 2. Switch 2 will learn C MAC address on which interface? 0/3. After that, this switch is going to forward traffic to switch 1. Switch 1 will learn C MAC address on 0/1 interface, and it will check destination. What is destination? A. So there is one entry, right, in their MAC address table. Exit interface is 0/1. Switch 1 is going to forward this frame to switch number 2 again. Yes or no? That means for 300 seconds, after 300 seconds, this switch will flush this entry. Means for 300 seconds, switch is going to forward, frame where destination MAC is A to switch number 2. If switch 1 is receiving a frame where destination MAC is A, so switch 1 is going to forward frame to switch 2. It will not perform unknown unicast flooding because there is entry in their MAC address table. Getting my point?
Yes, we can reduce the MAC aging time.
So if you will reduce MAC aging time, let's say MAC aging time is 100 seconds. So again for 100 seconds, these two users cannot communicate with each other. And if you will reduce MAC aging time, that means unknown unicast flooding will increase in topology in network. So you are not allowed to decrease MAC aging time. You can only increase MAC aging time in real time. If you will decrease MAC aging time, let's say MAC aging time is 10 seconds. Means after 10 seconds, if this switch will not receive any frame for a MAC address, it will flush the entry, right? That means all switches are going to flush the entry for after every 10 seconds. So after every 10 seconds, switches will perform unknown unicast flooding. So this is not solution.
When client A connected to switch 3 send the update message to switch 1.
Switch 3 will send update message.
Hmm.
Why switch 3 will send update message? And how switch 3 is going to send update message?
Through MAC updation, MAC table updation.
Means automatically switch 3 will send their MAC address to switch 1.
No, automatically no.
Then what I need to do here? No.
Will switch 1 learn the IP 10.1 connected to switch 3? Then it will learn that one.
Yeah,
10.1.
definitely then it will learn, but for 300 seconds there is still one entry available, so it will not perform unknown unicast flooding.
Does it have 2 entries for 10.1 IP?
No, there is no IP address in MAC address table. There is only MAC address and exit interface and VLAN information and method. Right. So we can see
the 10.1A is connected to switch 3 right now.
Hmm.
So the MAC will be same for A.
So switch 1 should learn a MAC address on this interface now. But definitely switch 1 will learn a MAC address on 0/2 interface, but after 300 seconds. After 300 seconds, definitely it will learn a MAC address on 0/2. But what will happen for 300 seconds? Or if MAC aging time is 500 seconds, then for 500 seconds, this user cannot communicate with 10.1. Means 10.3 cannot communicate with 10.1.
If a new device is connected, after 300 seconds only it will learn that MAC of that device. The switch will learn that MAC of that device.
Yes.
Okay.
problem over here is switch is not changing MAC address table when changes occur in topology. Whenever change is happening in topology, switches should update their MAC address table automatically. So that will happen only in one scenario, if switch 2 will inform to switch 1 that brother, there is some change. Now computer whose MAC address is A is not available on 0/3. So please remove a MAC address on 0/1 interface. So that's why we come up with topology change notification, that whenever change will occur, non-root bridge switch will inform to root bridge switch that there is some change in topology. And whenever root bridge switch will receive TCN BPDU, actually in this scenario non-root bridge switch will send TCN BPDU to root bridge switch, and whenever non-root bridge switch will send TCN BPDU to root bridge will on TC bit in their BPDU. So root bridge switch is sending BPDU after 2 seconds, right? After receiving TCN BPDU from switch number 2, it will on TC bit, and whenever a switch will receive TC bit on BPDU, it will set their MAC aging time to 15 seconds. It will set their MAC aging time to 15 seconds automatically. And once again topology will converge, these switches is going to set their MAC address, MAC aging time to 300 seconds again. Okay, so that's why topology change notification is required here. Same thing will happen, let's say in this topology, in same topology, let's say now this is my alternate port. So 10.1 is communicating with 10.2 through switch 1, right, by using this path. Let's say this link will goes down. When this link will goes down, what will happen? This port should be now RP. Alternate port is nothing but backup of RP, right? When our RP port will goes down, alternate port will become RP. So again this, when this port will, this link will goes down, now this port will become RP, but this port will take how much time? 30 seconds to come in forwarding state. First it will receive BPDU over here, right? First of all, it was receiving BPDU on this interface earlier. Now this link is down, so switch 3 is not receiving BPDU over here. Now switch is receiving one BPDU over here only, right? So there is no comparison, so this BPDU becomes superior BPDU. So switch 3 will put this interface to forwarding state, and port role will be RP, because switch 3 is receiving superior BPDU on this interface now. So this port will become RP, and this port will take 30 seconds to come in forwarding state. So again for 30 seconds, user cannot communicate, right, with each other. Or let's say switch 1 have MAC address, switch 1 have learned MAC address of computer A and computer B on these two interface. So switch 1 should also remove MAC address of A and B quickly from their interfaces, right? Because now communication is, now PC1 and PC2 is going to use this path to communicate with each other. So that's why we come up with topology change notification. So whenever change will occur in the topology, right, non-root bridge switch will generate TCN BPDU to inform root bridge, and whenever root bridge switch will receive TCN BPDU, it will on TC bit in their BPDU. By default in configuration BPDU, you will see TC bit is off. Okay, let me show you practically also. Here I think I have topology. STP is parity protocol. Not this one. Yes, this one. IP address of PC1 is 10.1.1. IP address of PC2 is 10.1.1.2. You can see MAC addresses also, right? MAC addresses of this device. Which switch will become root bridge here? Which switch will become root bridge?
Switch 1.
Switch 1?
Which one?
Okay. And which port?
If suppose in that root bridge switch only we have some any changes means,
So then also
then
it will on TC bit. This port is DP, this port is DP, this port is RP, this port is also RP, this port is RP, and this port is alternate, right? So if you will check MAC address table, first of all let me access PC1. On PC1 I have to configure one IP 10.1.1.10.1.1.1/24.
Will it take 45 seconds to become that RP, the alternate port become to become RP? It
45
will take
seconds.
how much seconds?
45 seconds. You are saying
So
45 seconds, na?
yes, that aging time also will come into picture, right? 15 seconds aging time, and then 15 times listening, and then 15 seconds learning.
Correct. Okay, so here we have IP address. Let me check. I am able to ping 10.1.1.2 or not. So you can see I am able to ping. Right now, let me access switch 1. In switch 1, MAC address table. So MAC address table. You can see switch 1 have learned MAC address of PC1. PC1 MAC address is 9B 4 times 0. 9B 4 times 0. MAC address of PC1 is not here, right? So spanning tree. Okay. So run so interface f0/0 include BIA. So MAC address is this one. Sorry, let me change the MAC address. This is MAC address of PC1, and let me show you the MAC address of PC2 also. So interface f0/0 include BIA. Fine. Now you can see PC1 is able to ping PC2, right? And on switch number 1 we are able to see MAC address of PC1. MAC address of PC1 on which interface? 0/0. And MAC address of PC2 3A 00 on 0/1 interface. Now I am going to down LAN interface here on switch number 2, config t interface is 0/2 and say shutdown. I've done this interface on switch number 1. See the MAC address table. Switch 1 have flushed the MAC address of PC1 immediately because of topology change notification. Because of topology change notification. Again on switch number 2 I am going to say no shut here, right? And it will take 30 seconds. RP DP DP fine on switch number 1. So spanning tree DP, correct? Both ports are DP and in forwarding state. Now let me capture this link. I'm going to capture any link, let's say 0/0. Are you able to see spanning tree messages? Who is sending? Source MAC. Source MAC is MAC address of switch 1. You can see this is MAC address of switch 1. Means root bridge is sending BPDO. Only root bridge switch is sending BPDO. Correct? In this BPDO, if you will open a spanning tree message, this BPDO message, and in the flag, BPDO flag, see TC bit. Topology change acknowledgement. Just wait, let me open new spanning tree messages. Here you can see TC bit is what? Off. So by default, root bridge switch send BPDU with TC bit off. TC bit off. But when change will occur, see, again I am going to down LAN interface of switch 2. Config T interface, which interface it is? 0/2. Interface is 0/2. Again I am going to say shutdown. So first, see, switch 2 have sent one topology change notification message, TCN. This is TCN message, right? With the help of this message, switch 2 is informing to root bridge that there is some change in topology. There is some change in topology. And in the next BPDU, which root bridge is sending, you can see in this BPDU, TC bit is on. TC bit is on, and acknowledgement bit is also on. That means it is acknowledging to switch number 2 also that I have received your TCN BPDU. Now on switch 2 will receive this BPDU, right, where it will see acknowledgement bit is on. Switch 2 will came to know that okay, root bridge have now knowledge about topology change, so switch 2 will stop sending TCN BPDU. So because of that you are not able to see any other TCN BPDU here. But if switch 2 will not receive configuration BPDU with TC acknowledgement bit on, right, it will be continuously sending TCN BPDU, and root bridge have on TC bit also on. So when switch will receive TC bit on BPDU, switches will set their MAC aging time to 15 seconds. MAC aging time to 15 seconds means after 15 seconds all switches are going to plus MAC entries. All switches are going to flush MAC entries. So because of that we are able to see whenever changes, whenever I am running shutdown command and no shutdown command on this interface, all switches like switch 1 so MAC address table, right, all switches are flushing their entries, right, and so MAC address table aging time. Now what is MAC aging time here? 300 seconds. Again on switch number 2, if I will down this interface, again I am going to say shutdown, and now here you can see MAC aging time is what? Now this is again problem of software. Here MAC aging time should be 15 seconds. Now let me verify it on switch number 3. Enable so MAC aging, so MAC address table aging time 300 seconds. Let me do one thing. On switch number 2 again I am going to run no set command here. No set. Here we are able to see 300 seconds, right, but MAC aging time should be 15 seconds now. So MAC address table, right, so MAC address table shutdown. No shutdown. Still there is 21 on 0/0 and 1 on 0/2. It is learning MAC address on 0/0. This is MAC address of which device? PC1? No. Switch 1 MAC address. Actually here in simulation software we are not able to see 15-second MAC aging time, but whenever change will occur or whenever root bridge switch will set TC bit on in their BPDU, all switches will set their MAC aging time to 15 seconds, and all switches will flush their MAC table for 15 seconds, right? For 15 seconds. After that, it will learn again new MAC addresses. So that still see we have problem. For 15 seconds, user cannot communicate with each other, but only for 15 seconds, not for 300 seconds. So this is the reason why we come up with this message, topology change message. Why we come up with topology change message. This message. So still we have problem, right? That whenever, let's say, this switch 1 or switch 3 have 100 number of MAC addresses in their MAC address table. So whenever a LAN user will come up or LAN user will goes down, right, switches is going to flush all entry, and whenever switches will flush their MAC address table, right, it will perform unknown unicast flooding for a particular destination. For a particular destination, switch will perform unknown unicast flooding, right? So let's say in my topology there are 50 switches, right? And all switches we have around 500 MAC addresses in MAC address table of all switches, right? So whenever a LAN user will come up or goes down, all switches will flush all entries and they will perform unknown unicast flooding, right? So to reduce this problem, we come up with topology change in STP. Now we have three types of topology change. We have
Will
three
it flush
types.
all the entries or that particular device MAC?
All the entry. MAC aging time is going to be 15 seconds for all the VLAN, for all the entries.
For all VLANs too?
Yes, for all VLANs.
Okay.
It will change global MAC aging time, right? Not for a particular VLAN. So we have three types of topology change. Let me discuss all one by one. Then we will move to next topic. See, first type of topology change is insignificant topology change. Second one is direct topology change, and third one is indirect topology change. Guys, insignificant topology change is, whenever access port will goes down or come up, that type of change is called insignificant topology change. That type of change is called insignificant topology change. Okay, direct topology change means when RP port of a switch goes down and alternate port is available, that type of change is called direct topology change. Like in this scenario, see, when PC1 or PC2 will goes down, right, or if I will add one new PC here, okay, so this type of change is called insignificant topology change. Whenever RP port of a switch will goes down and alternate port is available, like switch number 3, this port is RP and alternate port is available over here, right? So whenever RP port will goes down, alternate port will become what? RP, because alternate is nothing but backup of RP. So when RP port of a switch will goes down and alternate port is available on that switch, this type of topology change is called direct topology change. And indirect topology change is whenever RP port of a switch will goes down and alternate port is not available on that switch. So this port is what? DP. So on this switch number 2, we don't have alternate port. So when this RP port will goes down, this type of topology change will consider as indirect topology change. Got it? In topology change, first thing that I told you is whenever change will occur, non-root bridge switch will inform to root bridge switch about the topology change with the help of TC and BPDU. Whenever root bridge switch will receive TC and BPDU, it will on 2 bits. In their first BPDU, it will add TC ACK bit as well as TC bit. right? And once a non-root bridge switch will receive TC bit on BPDU, it will set their MAC aging time to 15 seconds globally. Then I said we have three types of topology change: insignificant topology change, direct topology change, and indirect topology change. Whenever access port of a switch will goes down, that type of change is called insignificant change. Whenever RP port of a switch will goes down and alternate port is available on that switch, that type of change is called direct topology change. And whenever RP port of a switch will goes down and alternate port is not available on that switch, that type of change is called indirect topology change. That type of change is called indirect topology change. Okay, so what is problem in significant topology change? Problem is whenever we will add or remove a LAN devices, right? A LAN devices, all switches is going to flush their MAC address table. All switches is going to clear their MAC address table. Fine. So what is solution of this significant topology change? Insignificant topology change. Solution is you should disable spanning tree protocol on LAN interfaces. Like from LAN interfaces, switches sending BPDU also, right? But switches should not send BPDU from this interface, because let's say on LAN interface here I have one port. If I will connect one switch with lower priority, let's say priority 0 over here, right? If I will connect this switch to switch number 2, now this switch will become what? Root bridge. So what I want, switch 2 should not send BPDU from this interface, or switch 2 should not send BPDU from this interface. Or next problem is, you can see on switch number 2, this port is no set do so spanning tree. 0/2 is connected with LAN user, and this port is designated port because this switch is sending superior BPDU from this interface, and the status is forwarding, right? But whenever this port will come up, now this port is down, again I am going to run no set command, right? So user have to wait for 30 seconds, right? Now you can see this port is in listening state. After 15 seconds this port will come in forwarding state. Means now user PC1 cannot ping to PC2 because this port is not in forwarding state, right? Still it is in listening state. Now it is in learning state. Still PC1 cannot ping to PC2. PC1 have to wait for 30 seconds, right? PC1 have to wait for 30 seconds because of a spanning tree protocol. So solution is, guys, port fast. You should enable port fast feature on all access port. Once you will configure port fast feature on this port on 0/2 interface, right? Switches will stop sending BPDU from this interface, and this port will come in forwarding state quickly. This port will come in forwarding state quickly. Clear?
Prabal, one thing, actually on the LAN port, for user ports, if you are enabling PBD card on the port pass means what will be happen?
BPDU guard is different thing. We will discuss BPDU guard also. Just wait for some time. For now, what I am saying, switches taking 30 seconds, right, to come in forwarding state. Like this ports take 30 seconds to come in forwarding state. How to reduce this timer? Or whenever we are disconnecting or connecting LAN ports, LAN user on LAN ports, right, switches are generating TC and BPDU. Because of that, switches are flushing their MAC address table. So how to reduce this problem? How to solve this issue first? So solution of this issue is configuring port fast.
If we configure that port fast means how much time it will take?
It will take 0 seconds to
0
come in
second.
forwarding state.
Okay.
because STP states, learning, listening, these are states of STP. Enabling port fast means disabling a spanning tree protocol on that interface. From port fast enable interfaces, switches is not going to send BPDU as well. Clear? So here what I am going to do, a spanning tree, port fast, a spanning tree, port fast. Now see, warning as well, warning, port fast should only be enabled on port connected to single host. Because if I will enable port fast, let's say on this interface, what will happen? Switch is not going to send BPDU from this interface now, right? So if switch 2 will not receive BPDU over here, and switch 2 is also not receiving BPDU over here, then loop will form in the topology again.
Then if we connect that that new user means, then how it will learn that MAC address if we enable that port fast?
Learning MAC address mechanism will be same. When switch will receive frame on this interface, first it will learn MAC address.
Yeah. Then learning that MAC address means it should send that BPDUs.
No, switch is going to learn MAC address through BPDU, brother, or through actual frame.
Yeah,
Switch
this is the
learns
end
MAC
user.
address with actual frame now. So when PC will generate any frame to switch, right? When switch 2 will receive any frame from PC1, then only switch will learn MAC address.
Okay. This is end user, right? Okay.
So what it's saying, you should enable port fast only on that interface which is connected with a single host. Let's say a port which is connected with another switch, on that port fast should be disabled. So here I have disabled the port fast, sorry, I have enabled the port fast on this interface. Now if I will down this interface, say shut down and do so a spanning tree. Okay, I am going to say no shut. Now see, this port is in forwarding state. Getting my point? Shut down, no shut down. See, now this port is not taking 30 seconds to come in forwarding state, right? So this is solution of insignificant topology change. We should do same thing on switch number 3 also. On switch number 3, on 0/2 interface, port fast should be enabled. Interface is 0/2, spanning tree, port fast. Right now, if this port will goes down or come up, do so spanning tree. You can see this port will come in forwarding state quickly. Fine. Clear, guys?
What is the max age that 20 seconds mean here in the output?
Max age time is 15 seconds, means it will store BPDU. This is like hold on time. Switch 1 is sending BPDU to switch number 2 and switch number 3, and switches are going to store that BPDU for 20 seconds. Means within 20 seconds, if switch will not receive any BPDU on, let's say switch 2 is not receiving any BPDU on 0/0 for 20 seconds, right? Then it will remove this port. This port will enter in blocking state. This port will be not RP then. Max age time is like hold on time. In OSPF, hello time is 10 seconds, right? That means after every 10 seconds, routers are going to send hello message, and hold on time is 40 seconds. That means a neighbor router will keep that information for 40 seconds, that hello message. Now second type of change is direct topology change. So see, again in this topology, when RP port of switch 3 will goes down, RP port means this port E0/0, first it will remove all the MAC address on the RP port. Let's say switch 3 have now learned some MAC address on this interface. So when this port will goes down, first of all switch will remove all MAC addresses from this interface. Then what will happen, guys? Then switch is not receiving any BPDU over here, right? So for how long switch is going to keep that BPDU? Earlier switch was receiving BPDU here, na? So that BPDU will be there in the database of switch 3 for 20 seconds, right? After 20 seconds it will remove that BPDU. Now switch is receiving BPDU over here on alternate port. As I told you, blocking port can receive BPDU but cannot send BPDU, right? Switch 3 cannot send BPDU from here, right? But it can receive the BPDU. So now switch is receiving BPDU over here. Now this BPDU will become what? Superior, because it is not receiving any BPDU on this port now because this link is down. So after 20 seconds, this port will become RP. And this port will take 30 seconds to come in forwarding state, right? It will take 30 seconds to come in forwarding state. Means total time for topology converge is 15 seconds here, right? For 15 seconds, PC1 cannot communicate with PC2. Getting my point? Whenever RP port of switch 3 will goes down, for 50 seconds PC1 cannot ping to PC2. We can verify it. How we will verify it? How I will verify it, guys? See, on PC number 1, I'm going to send some 10,000 ICMP packet to PC2. Ping 10.1.1.2, say repeat 10,000. And then go to switch number 3, and on switch number 3, which port is RP? 0/0. Interface is 0/0, say shutdown. See, for 50 seconds, after 50 seconds, again PC1 can ping to PC2, but for 50 seconds, right, there is no connectivity. Why? Because on switch you can see so spanning on this switch, so spanning tree. There is no RP port. Sorry, on switch number 3, 0/1 is now RP, but this port is in learning state. Now this port has become RP, but it is still in learning state. So it will take, now you can see ping is working, right? Ping is again working because this port has come in forwarding state now. So now new RP on switch number 3 is 0/1. So here convergence time is 15 seconds. So whenever direct topology change will occur, right, topology need 50 seconds to converge the topology. Now switch 3 will learn MAC address of PC1 on 0/1 interface. Earlier switch 3 was learning a MAC address on 0/0 interface. Right? Again, if I will run no set command, interface is 0/0, say no set. Again you can see, again how much time it will take? 50 seconds. Once this port will come up, switch will receive BPDU over here. But earlier switch was receiving superior BPDU on this interface, right? So that BPDU will be superior for next 20 seconds. So after 20 seconds, this port will become RP. Now it is receiving superior BPDU on this port, and this port will take 30 seconds to come in forwarding a state. Getting my point? Clear? So interviewer can ask you guys directly question that whenever direct topology change will occur in STP, right? STP takes how much time to reconverge the topology? So 50 seconds. In case of insignificant change, convergence time is 30 seconds. In direct topology change, convergence time is 15 seconds. So what is solution? Solution is uplink fast. You should configure uplink fast on that switch where alternate port is available, where alternate port is available. Now understand, uplink fast enable switch where alternate port is available, like switch 3. What I'm saying, if RP port will goes down of switch number 3, alternate port will become RP and it will come in forwarding state quickly if uplink fast is enabled. If uplink fast is enabled, then this port 0/1 port, alternate port, will come in forwarding state quickly. This is the benefit of uplink fast. So uplink fast feature is for direct topology change. You should enable uplink fast feature on that switch where alternate port is available. This feature will escape learning state and listening state. Listening state and learning state. So on switch number 3, what I need to do? On switch number 3, I can say a spanning tree, uplink fast, this feature. So I have enabled uplink fast, and now again I am going to send 1000 packet, right? And let me down interface is 0/0, say shutdown. Now you can see ping is not working, but wait, within 20 seconds it will convert the topology. Earlier it was taking 50 seconds, but this time it will take 20 seconds only, right? Because here do show a spanning tree, you can see ping is working, and this port 0/1 has come in forwarding state quickly, right? Say shutdown again. Sorry, no shutdown again. So now RP port 0/1 port is up. Do so a spanning tree. You can see E 0/0 alternate 0/0. Soon this port will become fine. New RP, but ping is continuously working, right? Why? Because of uplink fast. So if uplink fast is enabled on a switch, then alternate port will come in forwarding state quickly. And this edge, you can see this edge is indicating that port fast is enabled on this interface. Now this interface is edge port. If you will connect switch on this port, right, that will not participate in STP domain because switch is not sending BPDU from this port. Clear? Now last type of topology change is indirect topology change. When 0/0 is 0/0 of switch 2 will goes down because alternate port is not available on switch 2. This type of topology change is indirect topology change. So when this port will goes down, what will happen if this switch will goes down, guys? Tell me the process. What will happen?
E0/1 will become root.
No, switch 2 is not receiving any VPDU over here. This port is alternate, na? So alternate port is not sending VPDU. Alternate port cannot send BPDU because the status is blocking. In blocking port can receive BPDU but cannot send BPDU, right? So see, when this port will goes down, actually now switch 2 is not receiving any BPDU. So switch 2 will think, now I am root bridge. Now I am root bridge. So it will send superior BPDU, their BPDU from 0/1 interface, from this interface. But when switch 3 will receive BPDU of switch 2, switch 3 will came to know that no brother, you are not root bridge. Root bridge is switch number 1, right? So what switch 3 will do? Switch 3 will change this interface from alternate to DP. And it will take 30 seconds to come in forwarding state again, right? Now this port will become DP because now switch 3 is going to send superior BPDU from here. Earlier switch was receiving superior 1 BPDU over here, but that was not superior, that was inferior. But now switch 3 is receiving BPDU of switch 2. So in new BPDU, root bridge ID will be this one, bridge ID of switch 2. Earlier root bridge ID was bridge ID of switch 1. So when switch 3 will receive BPDU of switch 2 on alternate port, it will change their port from alternate to DP. It will take 30 seconds to come in forwarding state. After that it will send superior BPDU from here. And when switch 2 will receive superior BPDU on this interface will become what? RP. This interface will become what? RP. Right. So convergence time over here is 30 plus 30, right guys? And it will take around 60 seconds. So again, to reduce this problem, to solve this problem, we have a feature called backbone fast. You should enable backbone fast on that switches where RP port is available and alternate port is not available.
Can you explain it again, this one?
What I'm saying, now this port is RP, this port is RP, this port is DP, and this port is alternate. When this link will goes down, now switch 2 is not receiving any BPDU on any interfaces. So switch 2 will think I am root bridge. It will send their on BPDU to switch number 3. When switch 3 will receive BPDU of switch 2, it will come to know that switch 2 is not sending superior BPDU. So it will change their port from alternate to DP, and it will send BPDU of switch number 1 to switch number 2. When switch 2 will receive superior BPDU on this interface, this port will again become RP. And this is how STP is going to converge topology whenever indirect topology change will occur. Again, I am going to send 1000 ICMP packet, and let me take you to switch number 2. On switch number 2, I am going to down 0/0 RP port.
Can you capture that link and show what happens?
Why we will capture the link? What you want to see?
That BPDU and all, what BPDU the switch will send and all.
Switch will send TCN BPDU. But in this scenario, in indirect topology change, switch cannot send BPDU to root bridge because there is no connectivity.
Between switch 2 and switch 3?
Between switch 2 and switch 3 also we will not see TCN BPDU.
It will
because
send.
In indirect topology change, switch will send their own BPDU.
That we can't see in the capture?
Yes, you can see that in capture. Let me capture the link. Wait for topology convergence. Okay, now I am going to down this interface, shut down. We have to find BPD of switch 2. Which switch is sending this BPDU? Switch number 2. See, root bridge ID and bridge ID both are same in this BPDU. Okay, Dhana.
Yes, yes,
Can I remove it?
yes.
Okay. Right. So see, now again ping is working. No set. Now I am going to enable backbone fast feature on this switch. Right. So say a spanning tree, backbone fast. After enabling this feature, again I'm going to send some packets. Now again it will take 20 seconds to convert the topology, right? But not 60 seconds. Interface is 0/0 shutdown. Backbone fast is enabled, and why it's taking time. So with the help of backbone fast feature, you can reduce some time in direct topology change. By using backbone fast, you can reduce convergence time in insignificant topology change. And by using, what was one? Backbone fast, port fast, and
Uplink fast.
Uplink fast.
uplink fast. Uplink fast is for
RP failure.
Direct
for
topology.
Direct topology.
for direct topology change. Direct topology change means RP port
Failure.
is there and alternate port is there. If alternate port is available. Now next topic is type of spanning tree protocol. We have multiple types of spanning tree protocol, and we have some STP protection as well, like root guard, loop guard, BPDU filter, and BPDU guard. So you tell me first, you want to cover types of STP or STP protection first? And guys, nowadays we are not using this spanning tree protocol, right? We are still using, but mostly we are not using, because still you can see here I have enabled all the features, but still whenever change is happening, right, change is occurring in the topology, right, it's taking some time, sometime 20 seconds, sometime 30 seconds, sometime 15 seconds, but still convergence time is there. So we come up with another type of spanning tree protocol, that is RSTP, rapid spanning tree protocol. In that protocol, these all features are inbuilt. These all features are inbuilt. Means whenever change will occur automatically, RSTP protocol is going to convert their topology quickly. Right? So we will see that in RSTP. But this is CST, common spanning tree protocol. Whatever things we have discussed till now, this is behavior of common spanning tree protocol, CST. right? And on these switches as well, if you will check, so a spanning tree summary, we are not running common spanning tree protocol. Which type of spanning tree protocol is running here? PVST. This is not PVST, this is PVST plus. We are running PVST plus. Okay, so we will discuss these types of spanning tree protocol. So tell me, first you want to learn protection or types of spanning tree protocol?
Protection.
Protection. Okay, so first protection is root guard.
For all spanning trees protocol, or
Huh?
this protection is applicable to all
Yes,
types of.
for all types of spanning tree protocol. Root guard. Second one is loop guard. Third one is PPDU guard, and fourth one is, that's it. We have three protection, and here I have some sticky notes as well for STP protection. Let me show you. Like you can see, port fast. Port fast is a Cisco technique that puts a switch interface into forwarding state immediately, skipping listening and learning state. This is useful for interfaces that are connected to computers or server, so that these devices don't have to wait until interface is up and running. Then BPDU guard. BPDU guard is a feature that defends the layer 2 spanning tree protocol technology against BPDU related threats and is designed to protect switching network. The BPDU guard feature must be activated on ports that should not receive BPDU from connected device. So on a port, let's say you don't want to receive BPDU, right? There you should enable BPDU guard feature. Then we have root guard. Root guard, you can see root guard with the help of name also, it's telling us that it is to protect root bridge. It is to protect root bridge. Root guard is an STP feature that is enabled on a port by port basis. It prevents a configured port from becoming a root port. Becoming a root port. Root guard prevent a downstream switch of a misconfiguration or from the becoming root bridge in the topology. I will explain it through diagram also. Then we have discussed uplink fast. Okay, here, okay, leave. These are not useful, much useful. See here, root guard. First of all, root guard enable on all DP trunk port. What I am saying, it should be enabled on all DP trunk port. Let's say I have this topology, switch 1 here, switch 2, switch 3. DP, DP, RP, RP, DP, and alternate. Guys, this is my topology. In this topology, if someone will add one switch here, let's say here I am adding one new switch, right? This is attacker, right? If attacker will add their switch to, let's say, switch number 1, or let's say with switch number 2, here attacker is going to connect their switch, right? There is one port. This port is DP, designated port, because it is switch 2 is sending BPDU from this port. And let's say this attacker have set their priority what? 0. Priority over here is 0, and priority on switch 1, 2, 3 is 32768. So in this scenario, now you tell me which switch will become root bridge, attacker switch or switch 1?
Switch 4.
Switch 4 will become what? Root bridge. So my attacker is going to become root bridge, and then attacker will manage my entire switching network.
First, it will check the priority, then only it will check the MAC address.
MAC
Am I
address,
right?
yes. First priority, then MAC address. So in this scenario, what will happen if you will enable, this port is DP, if you will enable root guard feature on this DP port, right? So on a DP port, on a root guard enable DP port, whenever switch receive superior BPDU, switch will put that interface in error disable mode, and error disable is like shutdown, right? So switch 2 will down this interface automatically. So if root guard is enabled over here, right, then switch 4 can never become root bridge. So why I'm saying this root guard feature should be enabled on DP? Because DP port should never receive superior BPDU, yes or no? DP port is to transmit superior BPDU. It is not to receive superior BPDU. So that's why we come up with this feature, root guard feature. So always keep in mind, whenever a root guard enable DP ports receive superior BPDU, it will put that interface into error disable state, right? So now doesn't matter, right? Doesn't matter where attacker have connected their switch, right? Let's say on this interface we have not enabled what? Root guard, but on this interface and this interface root guard is enabled. So what will happen? This attacker switch will send their superior BPDU to switch number 2. This port will become what? RP, because now switch 2 is receiving superior BPDU on this port, and this port will become what? DP. This port will become what? DP. So when switch 1 will receive superior BPDU over here on this port, root guard is enabled, switch 2 will put this interface in error disable mode. So which switch is still my root bridge? Switch 1 is still my root bridge, right? So I never want to receive superior BPDU on this interface, and on this interface. So I will configure root guard feature on these 3 interfaces, so that these 3 interfaces should not receive superior BPDU. In the same topology, you can see switch 2 is receiving superior BPDU on which interface? On 0/0, which is RP. So if I will enable root guard feature on 0/0, then what will happen? Then it should not receive superior BPDU. It is receiving, it will put that interface in error disable state. Command to enable root guard is very simple. On, let's say, switch number 1, this is interface basis command. On interface you will run this command, interface range E0/0 and E0/1. What we will say? A spanning tree root guard.
Can we apply this globally, or we have to do it in interface?
Interface, not globally. Guard root, this is command. A spanning tree guard root. So hope it is clear why we have this feature, root guard feature, to protect my root bridge. Root guard is to protect root bridge. So we are enabling actually root guard so that no any other switch should become root bridge in my topology. Switch 1 should be root bridge always. Then we have what? Loop guard. Is it clear? This one?
Root guard apply in this topology.
Yes, yes.
Try it once.
Hmm?
Can we try now?
Yes, yes, of course. Now root guard is enabled on 0/0 and 0/1. Okay, then we have what? Loop guard. So loop guard is, to prevent loop, to
Sir,
prevent BPDU loop. Yes.
for one VLAN, one particular port will be root port, right? A designated port. One particular port will be designated port. For other VLAN, if you configure different port, that port will become root port. If that port become root port, do we have to configure in the root port also that guard?
No, no. On DP only.
But for different VLANs, if we
Yes, for different VLAN, if you are configuring for different VLAN, then definitely for some VLANs this port is RP, or for some VLAN this port is DP. So for some VLANs on that port, root guard feature should be enabled. On some switches, let's say in same topology, this switch is my root bridge for VLAN, let's say 10, and this switch is root bridge for VLAN 20. So this port is DP, this port is DP for VLAN 20, this port is DP, this port is DP for VLAN 10. So I will enable root guard for VLAN 10 on these two interface. I will enable root guard on these two interface for VLAN 20.
So we need to enable on all the interfaces that guard.
On all the DP port, on all the trunk DP port. You should not enable it on this port or this port. On this port, sorry, this port, this port, and this port. If I have yesterday topology like this, root bridge, DP, DP, DP. So in this scenario, on these all interfaces, we need to enable root guard feature. Then on this switch, this port is, if these two ports are DP, then on these two port also we need to enable. This port is RP, this port is RP, this port is alternate, this port is alternate, sorry, this port is RP, and this port is alternate. So on all DP ports, you should enable root guard features. All DP trunk port, you can say. Now in this scenario, guys, let's say because of congestion, switch 3 is not receiving BPDU on RP port. This is RP. This is RP port. So let's say because of congestion or because of any reason, switch 3 is not receiving BPDU over here. BPDU over here on this port, on RP port. Then switch 3 is receiving one BPDU over here on the alternate port. It is receiving one BPDU over here. So switch 3 will relay that BPDU to root bridge. So what is happening? Root bridge is sending BPDU to switch 2. Switch 2 is sending BPDU to switch number 3. And now switch 3 is also sending same BPDU to switch number 1. So this is what? One kind of loop. So to prevent this loop, we come up with loop guard feature. What loop guard feature will do? What loop guard feature will do? Loop guard feature will not allow RP port to send BPDU. Loop guard will not allow RP port to send BPDU. So this is how we can avoid BPDU loop. And loop guard should be enabled on all RP ports. It should be enabled on all RP ports. So even switch 3 is not receiving any BPDU from switch number 1, right? And if loop guard is enabled over here, switch 3 will not relay the BPDU to switch number 1. Okay, and command is very simple. Again, on switch number 3, interface. Again, this command will work on interface. Interface E0/0. Say spanning tree BPDU filter. Loop, this one.
Can you explain loop guard again?
Loop guard is used to prevent, to tell to switch to do not send BPDU from RP port, to stop BPDU on RP port. RP port should only receive BPDU, like DP port should only transmit superior BPDU or BPDU, right? So that's why we have enabled what on DP port? Root guard feature. In the same way, RP port is used to receive BPDU, not to transmit BPDU, right? So scenario can be there. In some scenario, maybe a switch can send BPDU from their root port if it will not receive any BPDU on root port, right? So that we can prevent sending BPDU from RP with the help of root loop feature.
Okay.
Now next is BPDU guard. So BPDU guard is for, again, for LAN port. For LAN port. LAN ports are by default DP ports, right? LAN ports are DP ports. So on LAN ports, you have enabled port fast, right? So the port fast, if you have enabled the port fast, it will also work fine. Or if you don't want to enable port fast, you can enable BPDU guard. So it will not accept BPDU on BPDU guard enable interface. A BPDU guard enable interface can never receive BPDU. If it will receive BPDU, again it will put that interface to error disable mode. It will put that interface to error disable mode. In this scenario, I can perform one task here by configuring set on switch number 2. This port is DP. This port is DP. I'm going to configure the root guard feature on this port, root guard. And if I will enable root guard here, that means whenever it will receive BPDU, this port will goes in error disable mode. So if I will down this interface, switch 3 will send BPDU, then we can verify it, right, that switch 2 is putting this interface in error disable mode or not. Right, getting my point, guys? We can achieve it or not. See, interface is 0/1. Spanning tree, what is command? Guard root. Done. And now I am going to down interface is 0/0. Say shutdown. So spanning tree 0/1 of switch 2, 0/1 of switch 2 is fine. And we can run this command also. So spanning, so I think interface error, so interface status error disable.
Show interface status.
That is error disable, right? It will put that interface in inconsistent state. Inconsistent state. It will put that interface in inconsistent state, and inconsistent state is also like blocking. You can see a status of this interface is 0/1 blocking. Why? This port should become RP, but this time this port is DP and the status is blocking because of inconsistent state. Again, if I will remove this command, interface is 0/1.
Can you show interface status? Give show interface status. Can you give the command? Show interface status. /1. Okay.
Okay. If I will remove this command, fine. Now you can see this port is RP. Now we have some types of spanning tree protocol, guys. Like, let me tell you how many types we have that we will discuss tomorrow. First one is CST, So till now, whatever protocols we have, whatever things we have discussed, that is behavior of CST, common spanning tree protocol. Common spanning tree protocol. Then here, which protocol is running? PVST. So we have PVST. PVST. CST is Open Standard Protocol. PVST is Cisco Proprietary Protocol. Cisco Proprietary Protocol. See, Cisco come with PVST to perform load balancing, to achieve load balancing in switching network. Because in PVST, for each VLAN, switches are going to run separate instances. So we can, configure one switch as a root bridge for some VLAN. We can configure other switch as a root bridge for some other VLANs. But in CST, switches will run only one instances for all VLAN. That means in CST, in the entire switching topology, there can be only one root bridge. There can be not more than one root bridge in CST. So that's why Cisco come with PVST, but PVST was not compatible with CST. So let's say switch 1 is Cisco switch and switch 2 is Nokia switch. So on Nokia switch we cannot run PVST protocol, right? Because it is Cisco proprietary. So PVST was not compatible with CST. So here on Nokia devices we were using CST, and on Cisco devices we were using PVST. So a spanning tree protocol was not working there, right? Right. So Cisco have to also use CST protocol. Okay. But again, if Cisco will use CST, they cannot achieve load balancing. So Cisco have replaced PVST to PVST plus. PVST plus. It have replaced PVST to PVST plus, and now PVST plus and PVST both are same, but PVST plus is compatible with CST also. Right. So we have achieved load balancing till now, but again we have problem of convergence, right? Whenever change will occur, it's take 30 seconds, 50 seconds, 60 seconds to converge the topology. So that's why we come up with one open standard protocol called RSTP. RSTP, rapid spanning tree protocol, right? So whatever features you have run, right, to avoid convergence time in direct topology change, in indirect topology change, and insignificant topology change, all features are inbuilt in RSTP. Okay, so we need to learn these all protocols. So tomorrow I will finish, because if you have understood CST, that means PVST is also clear to you, PVST plus is also clear to you. You need to learn only RSTP, that how RSTP is going to work, and how RSTP will converge topology quickly whenever change will occur. In RSTP also you have to enable port fast on LAN interface, right? For LAN interface we have same concept. On LAN interface in RSTP also we need to run port fast feature, but we don't need to run uplink fast command on switch where alternate port is available and RP is available. We don't need to run uplink fast, and which feature was, guys, for direct topology change? Uplink fast, and for insignificant change we have port fast. For direct topology change we have uplink fast. For indirect topology change we have backbone fast. So backbone fast and uplink fast is inbuilt in RSTP. Okay. So tomorrow I will make you understand RSTP protocol. Then we will move to next switching protocol, that is Ether channel. Any question?